Welcome to today's webinar. Today we're excited to have a discussion around terrestrial scanning and mobile mapping. As the slide says, a perfect blend of reality capture. SLAM-based mobile scanners and terrestrial laser scanners are both valuable tools in a 3D mapping and surveying, each offering their unique advantages that complement each other. We'll explore these advantages and how the line between each scanner type has eroded with new options. I'd like to start by saying thanks to XYHT Magazine and Connect Me Events for hosting today's webinar, and to everyone who was able to join today or listen in on the recording. We appreciate everyone's time and hope everyone walks away with some useful information, understanding of these technologies. Our speakers today will be myself, Dave Bonney, Channel Sales with FARO Technologies, Kelly Obermeyer, Field Applications Engineer with FARO Technologies, and Chris Fries, a Civil Design Lead with Tetra Rooney. I'll start by introducing myself. So I am David Bonney. I came over from the GeoSLAM side and have been with FARO now for about 4 years. So my expertise has been more on the mobile side and coming into more the FARO ecosystem. Kelly, if you don't mind introducing yourself.
Hello, my name is Kelly Obermeyer. I'm a field application engineer here at FARO Technologies. Prior to joining FARO, I was a client of FARO using traditional laser scanning to capture refineries and other pipeline areas. So I have firsthand experience with these scanners. Prior to that, I was working in pipeline integrity with a handheld scanner. So I have roughly 10 years of experience in scanning and applying our technologies to create different deliverables and achieve your end goals. I work closely with Chris Fries here in Denver. He is the lead design at Tetra Rooney. Chris, if you'd like to add any other bits and pieces of information, thank you for joining us.
Sure, thanks for the invite. Thanks for everyone joining us today. Did a good discussion on our topics here. I've been with Tetra Rooney about 13 years in the midstream oil and gas market. As mentioned, I'm a civil design lead, also in charge of our reality capture division here at Rooney. I've been using FARO product for about 7 years. Happy to contribute today. Thank you.
Great, thanks for that, guys. So just to cover our bases here, so the introduction, kind of the agenda here, we'll cover an introduction to reality capture, so the ecosystem that FARO is kind of presenting today, laser scanning in the field. So Kelly, my colleague, will go over kind of how we're using this technology today, and she'll provide some real world examples. And if you've not used laser scanning in the past, of course, this will be useful information. For those who are not and new to laser scanning, Kelly will also kind of go through some of those basics. So you might see some repetitive information if you're from the field. I'll then talk about some of the trade-offs between speed and accuracy. When we talk about laser scanning, we talk about speed, we talk about accuracy, we talk about usability. So we'll cover some of that, as well as what FARO considers a hybrid reality capture using what we know now as flash technology. And then we'll talk more about both the scanners themselves and real-world trade-offs. And Chris will cover so bring up some data and talk about some of his experience with that information. And then at the end, we'll take a panel discussion. We'll answer some Q&A. So we have about an hour and a half slated for the webinar. Please feel free to drop your questions into the chat. At the end, we'll kind of go through those questions and provide some answers, as well as just have an open discussion about what was discussed today. And after that, we'll let you guys get on your way. Like I said, it's about an hour and a half. If we get to a point where there's not a lot of Q&A, we'll give you some of that time back. So talking about FARO Technologies, if you're new to FARO, those who have known FARO for many years, we'll go over some of the existing technologies that we've talked about in the past and some of the new technologies that we're introducing to the market. But FARO specializes in the design, development, and marketing of computer aided measurement and images devices, and as well as software platforms. So FARO was founded in a garage, like most startup companies, in 1981 by Simon Robb and Greg Frazier. And they set out to pioneer how we collect 3D information and imaging technologies. Today, we'll focus on the reality capture tools in both the terrestrial and mobile spaces, while discussing how these cutting-edge technologies are assisting customers in a variety of applications. Much like a modern job site, Selecting the appropriate tool for the task at hand is imperative. This is why we equip ourselves with toolboxes containing different tools for different scenarios. This theory is directly in line when it comes to reality capture. When it comes to ensuring the proper tool for the job, FARO wants to make sure that the right piece of hardware is available. FARO's ecosystem of products is centered around our cloud platform, which we call Sphere XG. We believe that our data living in a cloud ensures transparency among all stakeholders on a project. These small wins help boost productivity and efficiency. We won't go into too much detail about that service today, but feel free to drop some questions and we'll go into that into the question and answer section. But FARO has always set out to manufacture tools that our customers need on a job, right? So we tend to listen to how customers are using our tools and where we can make improvements. Can a combination of tools be used throughout a project lifecycle? Over the past few years, FARO has looked at our portfolio and realized there was room for additional tools and software. While our core customers will always need the highest accurate results, we realize that speed of capture and deliverables will vary. Just kind of going around the horn here. So on the bottom half of the picture, you'll see some recent acquisitions of FARO to include the iPhone, iPad LiDAR solution, Sitescape, and the photogrammetry solution, HoloBuilder. So both of these are new tools within the past couple of years. So everyone today has these tools in a drawer, which can be quickly deployed on a job site with rapid data collection and rapid visual consumption. Moving to the left, we have a recently announced Orbis scanner. So in collaboration with our recent acquisition of the GeoSlam company, we released a new SLAM scanner to the market, offering the most versatile mobile scanner on the market, allowing for good data captured at excellent speed. Moving to the top half of the graph, the image, we start to get into more of the great data quality, the great speed of our portfolio, what we call flash technology. And we'll cover that a little bit further down in the presentation today. And then last, but certainly not least, is our Focus Premium and Core scanners, kind of the staple of the FARO AECO product line. These terrestrial scanners are the core of our system and provide excellent quality at great speeds. FARO has quite a bit to offer when it comes to creating virtual assets. I'll hand it over to Kelly now, who's going to cover some of the terrestrial laser scanning and mobile scanning. So Kelly, off to you.
Thank you, Dave. I'd first like to start with a poll question. You'll see a pop-up on your screen, and we would like you to describe your level of experience using your 3D reality capture scans. So if you guys could take a quick moment and answer the polls. I'll go ahead and continue on to the next slide while you guys are voting. Some different laser scanning in the field, real world examples of different use cases. Next slide, please. When we begin thinking about a project and location, we have to think about what is our reason for scanning. We can scan anything. It's what you do after with the data that counts. So as you can see here, I have some facilities, pipelines, mechanical rooms in this first slide. And within these different areas, what is it that we are trying to achieve? Are we looking to capture tie-in locations at a facility, or are we working on a larger scale to complete a 653 inspection? Perhaps we're trying to figure out how long that pipeline is, or talking about mechanical rooms. Do I need to model this entire mechanical room or just the compressor? Are we looking for specific elbow locations? There's different areas that we can identify within this mechanical room that we can focus on, or we could capture the entire room. So when we go into a project, we have to think about what are the deliverables we're trying to achieve. And if you have any of the answers to these questions that I've asked, go ahead and throw them in the chat for later for our Q&A panel at the end. Another area we can consider is also quality control. Moving to our next slide. Additional locations include urban, structural, and power locations. Within our urban areas, we can scan land surveying areas, we can work with different construction surveys, so using the existing conditions, layouts, verification, as-built. We can also monitor and perform deformation surveys using the soil substance, building monitoring, structure monitoring, and all of this can be done within point cloud data and the right analysis software. For our structural areas, we have bridges, tunnels, towers, wind turbines. We can jump into environmental engineering, wastewater treatment plants, contaminated sites. We could think about transportation engineering, roads, highways, airports, railways, canals, water resources, water supply, drainage facilities, and then geotechnical as well. So structural foundations, retaining walls, streets, sidewalks are also going to be part of our urban or municipal engineering. So just a couple of different ideas of how we can broad out the technology. So what industry are you guys working with, and how can we apply scanning to your particular area? Let's go ahead and take a moment and jump back to those poll questions. All right, so looking at our polls, we have about 14% that actually are using traditional laser scanners only. We have mobile scanning solutions, roughly 7%. And then we have a combination, 16% using both. And then our largest one is going to be 63% that don't use TLS or mobile scanning. So hopefully after our PowerPoint today, we can introduce to you how we can change your workflow and add to it by using a laser scanner to capture this data and bring back the information that you need to create your as-built or your BIM model. There's so many different things that we can do with point cloud data. It just depends on what you're trying to achieve. Next slide, please, Dave. This will jump us to our second poll question. So if you would please describe your line of work. We have general contractor, trade contractor, surveyor, service provider, owner, other as part of our poll quizzes. So I know I kind of went into detail on those different locations, and if I jumped over you, please also leave a comment in the questions area so we can tell you how we can apply laser scanning to your particular line of work. Moving forward to the next slide, I'm going to go ahead and start talking about the differences in Reality Capture Toolbox. So starting with our FARO Focus Premium, this is our standalone static scanner. And then we made a couple modifications moving forward to the Premium with Flash. You can see there it's got a little camera on top. This is a PanoCam Ryko Theta 360 that we have used our technology to implement faster capturing of color with the Premium and Flash toolbox together. And then finally, we have the FARO Orbis with Flash. So this is our mobile scanner, and then we have the option to do the static scans within the mobile scanning, which Dave will discuss a little bit later. I'm going to first kind of discuss how each one of these works and which option is going to be better for the different applications. First, the FARO Focus, we have a couple, this is our 9th generation, go ahead, next slide, please, is our FARO Focus Premium. And how it works, go ahead and we'll start the video here, is we have a laser that reflects out and hits a mirror and shoots off in the direction that the laser is scanning. So here we'll be able to see a really nice representation of that. We'll give it a moment. It's going to be scanning 360 horizontally, as well as vertically with a minimal dead space below. So we have 360 by 300 field of view. The higher the tripod is, the lower the dead space kind of around where the tripod is standing. So this is how we're able to capture all of that data and bring it into our registration software. It captures millions of points per scan, up to 2 million points per second. And it works using a time of flight phase shift measurement. So what does that mean? Go ahead and go to the next slide, please. In the bottom right-hand corner, this is my favorite image to kind of describe how this works, is that we have an outgoing light that will hit a wall or the surface or whatever it is you're trying to scan and return on a path. And you can see in the bottom right-hand corner that there's going to be a phase shift. So the amount of time it takes for the laser to return to the scanner involved with a little bit of math and a phase shift measurement is how we're going to obtain that data point. We're going to capture millions and millions of points together, bring them together to define one registered point cloud. Go ahead and let's go to the next slide, Dave. So inside our FARO focus box, you can see that we have the FARO focus itself. We have some batteries. There's some chargers in there. The bottom right-hand corner is where we can put the panel cam and the mount. Those are optionals. But just a quick little overview of the hardware and its features. It's very small and compact, so it's easy to maneuver around. I myself can lift it up, and with our carbon fiber tripod, it makes it a lot easier to move around the site and very quickly to capture the data that you're looking for. Go ahead, next slide, Dave. So here's an example of using the focus for terrestrial laser scanning. This is a large building that we went ahead and scanned. And when we're doing static scanning and you're trying to capture the room, we want to have at least one scan in every room and then a scan in every doorway so that those scans connect together when we're registering. This took approximately 5 hours to capture in the field. So each one of those orange positions is a scanner position where we set the tripod down and waited for the time for it to scan. So the time that it takes to scan is going to be based off of your quality, resolution, and color options. We have as quick as a 25-second scan with our flash profile, and then we can do roughly a 2-minute average scan without our flash profile. So if you're looking for that high quality data, we can define a workflow for you using the flash profile or without. Just kind of depends on what your end deliverable is, right? The amount of time it took to process and register this will depend on your computer. So we can think, having a pretty good computer with specs, this still took a total of 9 hours to capture in the field and register afterwards. We're going to get a nice accuracy of 1 to 2 millimeters for this particular example. And then we have the same example shown in the Orbis. So we'll do a comparison between the FARO Premium and the Orbis mobile device by itself. So some advantages that the Focus Premium has is the 25-second setting with flash. So we can scan an entire area. What you see is what the scanner sees. So in a room, if there's something behind a wall, the scanner isn't going to pick it up. But everything that the scanner sees, we can capture it with color using our flash profile within 25 seconds. And then using our app that connects to the scanner, we have the option of pushing that up to the cloud that David spoke about, Sphere XG, where it'll process and on the way up to it. So you don't have to worry about that. But we do have the option to just bring it locally to your computer. So multiple options for our processing within the Premium. Again, we can apply survey control, so we're not changing that workflow there. If you guys need to geolocate or reference your scans back to control, that is also possible. And then with Scene 2023, we have a new interactive registration, which provides better control over your results. So as we're going through and scanning each room and putting scans in the doorway in different areas, we can actually choose the connections between each scan so that the scan in room A and the scan in room B aren't trying to connect to each other, and they know that they're next to each other rather than on top of each other as if they have the same type of geometry. Whereas before, using cloud to cloud, we wouldn't know if it's going to be next to each other or the same room. So Scene 2023 is definitely moving towards great registration results as far as our Focus Premium goes. But before we jump to the FARO Orbis, I'd like to jump back to our poll questions here and see where we're at with that. Lovely, thank you. All right, so for our line of work, we have no general contractors or trade contractors, according to the poll. Our surveyors are roughly 50%. Shout out to the surveyors. We have service providers, owners, and others. If you guys chose others, if you wouldn't mind, please placing what you do in the chat for our Q&A later. We want to make sure that we cover your area or your line of work and how we can contribute to your end game. Thank you. All right, next up we have our FARO Orbis. So as Dave said, FARO acquired GeoSlam as a great acquisition, and we've truly opened the door into mobile mapping. Next slide, please. So Orbis. Orbis works using a SLAM algorithm. So what is SLAM and how does it work? Well, SLAM stands for simultaneous localization and mapping. This technology is used in robotics, autonomous vehicles, and more relevant to this discussion, mobile mapping. There are different types of SLAM, but for mapping applications, FARO utilizes a CT SLAM, or a continuous time, which uses a LiDAR sensor and IMU, as well as a leading industry algorithm to capture our data. This allows users to capture data 10 times faster over traditional methods. We then took this further and allow users to capture the mobile, but also we're going to take terrestrial flash scans inside that Orbis scanner. So we can combine the mobile and flash scan data to get more dense point clouds and get better results, which again, Dave will go a little bit more into that flash technology, whereas I'm just covering the base of the mobile mapper at this point. Next slide, please. So for our hardware features, we have the LiDAR sensor for the puck, and then you have your adapters for your accessories. You can see we have our phone that connects to our app, which allows us to see the scan come in at real time. We have the option to hold it with the handle, or we can adapt a monopod. So if you are doing 20-minute scans, you don't have to worry about your arm, kind of losing its stability after a while. We are able to tie into control. You can see the original scanner marks. If you were familiar with the GeoSlam unit before, we turned it blue. They kept the nice original origin marks on there, so we can tie into control as well. We have the single battery, as well as the external data logger and the 360 camera. So just kind of going through the different components. Next up, we have the slide that shows the similar, next slide, please. Thank you. Next up, this is the traditional SLAM and mapping overview. So this is the same building that we used to the premium to capture, but between the premium and the Orbis, you can see that we only needed 30 minutes to capture. This was one single scan that we wanted to do good loops in. So you can kind of see that we've got some in and outs, and it looks like a lot of looping, or maybe a child liked to draw on this and color in, but that's the path we want to take in order to obtain good data. When the puck is in your hand and moving around, we want to do different circles so that we can see everything, because you are going to be in the data behind it. So if you're interested in something behind you, it's going to be good to do a loop as shown in this top-down view of the area. The processing took about 3 hours, and we're at 5 to 10 millimeters for accuracy. So do you need that 1 to 2 millimeter range, or is 5 to 10 acceptable? The amount of time saved is pretty remarkable as well. So this was a total of 3 hours to capture, process, and render a point cloud. All right, go ahead. Some advantages for our Orbis scanner. They've had over 10 years of experience in pioneering the SLAM scanner. There's unique SLAM environment presets to easily adjust SLAM processing based on the environment. And that's inside of our processing software. So when you go in and you process, we can apply color, we can apply filters. There's different ways to adjust your data, again, based on the environment and what your deliverables are. We have local and global compensation applied to the data set to enhance the output and reliability. And for scan control, scan control points and allow application of rigid or non-rigid SLAM for improved results. Great. So applying this to our different types of applications. Next slide, please. One more. So Orbis is great for large projects with low level of detail, scan to BIM, construction progress monitoring. It's great for limited on-site time and large outdoor areas. Whereas the Focus Premium is going to be great for those high detailed areas. Slide, please. Long range scans, small objects, and high fidelity applications. So within our technical toolboxes, or within our technical toolbox, we have a tool for you. It just depends, again, on what we're trying to scan. So for our pole and our surveyors, the Orbis is going to be great for those large areas that you're trying to scan. We have a lot of topography workflows that we can get through. And Dave's going to talk a little bit more about how that'll work out a little bit later here. Next slide, please. So some of our customer use cases for AEC include as-built capture and modeling, installation and placement. We want to do accuracy verification, digital twin creation, and then again, as-built documentation. So as-built for construction, as-built for MEP, construction quality control. We also have an application that allows us to work with the point cloud and pick out points and create topography or color maps or heat maps on the floors or ground, just different workflows that we can work with depending on your best case, or use case, excuse me. Next slide, please, Dave. Thank you. So for our geospatial customer use cases, the public sector, this is a nice view actually from Connect with the different colors and the different heights. So in the bottom one, you can see we can capture a very large volume quantity and be able to render that in, tell you how much is there. Again, we have manhole and culvert mapping, terrain mapping, corridor and roadways, power line mapping, surface inspection, land use management. And it's also a really good mining tool. So lots of different cases. It just depends on what it is you're trying to get at the end game. Like I said, we can scan anything, but what tool is going to be the right tool in order to provide the accuracy you need as well as the deliverable you need. And I will go ahead and thank Dave and let him talk about SLAM versus terrestrial a little bit more.
Thanks, Kelly. Switching slides here. So, and apologies, I got two monitors here. So I just wanted to comment on one of the poll sections. I do see some great questions coming in, which we'll get to in the Q&A section. But I realize we have 50% surveyors, which I was kind of shocked to see. So happy to have you guys here. And this next section, we're going to get into more the trade-off between the two scanners, what we're calling flash technology. I'm hoping not to get lost in the weeds because of the fact that it does apply to your world, but a lot of this is just how we're using these particular systems in the real environment. The best use of these systems is the fact that they are applicable to a lot of applications. As Kelly just described, we do take laser scanners into the survey world as well as the as-built world and the AEC world, mining world. So we can bring these scanners into quite a bit of applications, and that makes them very versatile. I'm going to go on to describe just kind of how FARO looks at our two different types of scanner, which Kelly just went over, terrestrial and SLAM. So when we talk about laser scanning, we talk about two different types of major scanners, terrestrial and SLAM based. There are other mobile scanners and different types of scanners, but when FARO talks about kind of the scanner applications that we have on the market today, SLAM and terrestrial kind of lead that pack. So around 2010, a little company set out to try to solve one of laser scanning's biggest challenges, right? Speed of capture. If anyone on the call has been in this world for any given time, as scanners progress throughout the years, the technology is better, of course. Speed of capture gets better, accuracy gets better. That's been what has kind of led laser scanning to be so popular today. What the little company called GeoSLAM tried to set up was more, how do we get this data quicker? How do we get it off a tripod and capture that information much, much easier and quicker? So GeoSLAM brought SLAM to the market with several tools. So we allowed the user to, again, walk through a space, fly through a space, run through a space, whatever you may be. Essentially 10 times more data capture over a TLS scanner. But what's the trade-off, right? It can't be that fantastic, right? So I get asked this all the time by customers, do I buy a SLAM? Do I buy a terrestrial laser scanner? Which is better? This is a complicated question, right? Because I will turn that question right back on a customer and say, well, what's your deliverable? And I saw that in several of the questions, right? What is the deliverable? What do I need to get out of the data? Would one tool work over the course of a project lifecycle? Would a combination of tools work over a lifecycle of a project? So SLAM-based scanners have advanced over the past decade, and we bridged that gap of speed and accuracy. Do I need color? Do I need hundreds of millions of points? Do I need hundreds of meters of deep data? So both terrestrial and mobile scanners kind of have evolved over the years to allow users to make that decision on their own. I'll go into some of the differences between the two scanning methods, some of the trade-offs, what FARO has introduced to the market in the past year that even bridges that gap even further. When FARO engineers and developers look at our products, they focus on three core values. What customers are asking us for, right? Speed, simplicity, and quality. How fast can I get on site, capture the needed information, process the data, maybe process it further with whatever other tools I'm using, and then serve it out to the stakeholders. How difficult are these systems to operate? Will I need a PhD to operate them? Can I operate them out of the box? And then quality. What do customers need to get out of the data? And more importantly, when do they get that data, right? When they use a piece of FARO hardware or software, they can expect a certain time limit that we've kind of set up based on how they use that tool. When FARO acquired GeoSLAM in 2022, they had one goal in mind. How can we take a tool that's good and make it great? How can we take our existing portfolio and give customers even more capability and options in one tool or maybe a couple tools? So again, going through the overall FARO solution, with the acquisition of Sitescape and HoloBuilder and then GeoSLAM here in 2022, we announced the FARO Orbis Scanner and Sphere XG cloud platform. Users now have options that were never before possible. FARO customers now have access to industry-leading scanners and software across the entire reality capture environment under one roof. FARO's redefining how users think about reality capture devices as tools in a toolbox, allowing decision makers the ability to get accurate information faster. We don't look at terrestrial scanners and SLAM scanners as an or tool. We don't look at our scanners as a versus option. They're both great solutions in their own right, so we focus a lot of effort on and. How can we use tools as a collaboration to get to the end result quicker? So on this slide, again, just Kelly mentioned Flash a few times, and I'll kind of reiterate that here in a moment. But how do we get the most out of each of these tools? And that's what FARO developers have been working on for the past 5 years, right? How do we use a single laser scanner to get more out of it? How do I use a single mobile scanner and get more out of it? So we've introduced something that we call Flash, which I'll cover here in a moment. And then on top of that, as I mentioned, software, right? So we've inside FARO are working towards a single kind of pipeline to get to the end result. How do I get to a deliverable quickest to a customer? If you're having to go within 4 or 5 different software platforms, then we're complicating the issue even further. So that is a huge tool and task that FARO takes seriously. So terrestrial and mobile scanning, right? So again, it's 50%, I think it was 67% of people on the call today have never used a TLS, which is terrestrial laser scanner, or a mobile scanner. So I'll cover just some of the basics here in a moment. When we look at terrestrial laser scanning, we don't see one tool replacing another. There's always been projects that require the highest of accuracy and time and no issue. So again, there's 50% surveyors on the call. Accuracy is very, very important to that group. Projects can be scheduled, budgets can be allocated, and time is managed appropriate. Accuracy far outweighs the need for in and out of a site in the same day. Site access also allows for tripod-based equipment to be safely set up. Mobile scanning also has its place in the market. There it goes. Mobile scanning also has its place in the market, and it's continuing to be adopted globally in verticals never thought. We have customers navigating difficult environments like tunnels, mines, shafts, as well as hard to reach areas like above ceilings, manholes, and very, very tight equipment. When customers need easy to use equipment that is less accurate, but still accurate, they tend to reach for a mobile scanner. But our more savvy customers, our more savvy users will reach for both tools. So this is more in that line of and. How can I use both tools to both get on site within the same day, same week, whatever it may be, but the deliverable will be easy to get to. Mobile scanning may solve 40% of a project, 50% of a project, but terrestrial laser scanning might solve that additional 50% or vice versa. So that we see a need in the market for both tools to be utilized. Chris will go into more detail about how his company deployed both of the scanners you're seeing on the screen to solve a single need. And I'm just going through questions to make sure I'm answering anything you guys have as we go along. And then again, we'll go through the Q&A section here in about 20, 30 minutes. Kelly showed these two kind of graphics earlier, and I'm just going to go into a little bit more detail about what they represent, right? When we talk about laser scanning, the question that gets asked quite often is, what is the speed, as I talked about before, what is the deliverable, what is the accuracy, etc. So Kelly went through this, and I'll just kind of remind you, just because we do get these questions quite a bit. On the left, you see a typical setup for an office space where we need to capture the entire as-built environment, right? All windows, doors, desks, whatever. So using a terrestrial laser scanner on the left, we have 125 scans, 2.5 minutes per scan. And keep in mind, I'm going to go over flash here in a minute, but 2.5 minutes is pretty typical for a laser scanner at the highest resolution, color, etc. This includes moving the scanner to each one of these stations. Generally takes about a size of this, a scan of this size, about 5 hours. When we talk about processing, 9 to 12 hours, depending on how you set up that scanner. So you're talking about multiple work days to get down to 1 to 3 millimeter of accuracy. The global accuracy on a project like this, as anyone who knows laser scanning, will generally be about 1 centimeter. When we talk about terrestrial laser scanning, we're talking about a single capture. You are the tripod. You're walking around the space as Kelly described it, a child drawing on a chalkboard. So you are entering the space and bringing the scanner into these new environments. And as you do so, you can move at the pace deemed by how much data that you need in that scan. So a mobile scanner does allow you to get into spaces that you wouldn't previously be able to, as I talked about before. Above a ceiling, you might need to get down into underneath a desk or whatever it may be, inside of very, very tight environments. But the theme here is the fact that it's very easy to use and very quick. So something of this scale would take about a half hour to capture the same space that just took us, 5 hours. So a huge 10 times quicker data collection. But there's a trade-off. That trade-off is definitely accuracy, right? So local accuracy, we talked about 5 to 10 millimeters, right? That is the spec of the scanner. If you're using survey control, if you're just using targets, we can definitely bring that accuracy down closer to 4 to 5 millimeters. We have customers that do that. But more importantly, when you combine the two data sets, if we're using the terrestrial data set in a machine room, or you need it in a very high accuracy location, and then you're using your your SLAM scanner to get the overall scan, then you're bridging the gap between accuracy and time, allowing for maybe a couple hours of scan time, but accuracy where you need it. So a very, very effective tool. So just talking about a site like this, right? When we think of a large scale project, right? This was a project in Chicago. I believe they scanned a hockey arena. But when we think of large scale projects like this, we can think of a combination of tools. You're not going to capture this with just a camera. You're not going to capture this just with a measuring tape, right? You're going to have to consider multiple tools to capture an environment of this size. So using a terrestrial scanners for the higher accuracy areas where you need a very, very tight threshold, and then capturing the overall site with a mobile scanner. Do we really need those chairs captured at 1 millimeter accuracy, right? I think 5 to a centimeter is perfectly fine for that application. And then combining those tools, as Kelly talked about before, and Chris will go into a little bit more detail later, bringing that all into what we call scene, FARO scene, is a combination of registration of all that scan data. But the output is a point cloud. So terrestrial or mobile, the output is the same. So I'm going to cover hybrid reality capture. Again, FARO, we discuss it as Flash. Flash is an acronym for being able to get more out of the scanners that we purchased and being able to use them in ways that we never thought were capable. And I'm just looking through questions real quick. Anything I can cover on that last section? Okay, cool. We can cover some of that during the Q&A. So again, when we talk about hybrid scanning, when we talk about hybrid reality capture, right, we are talking about a scan method that is untraditional to what has been on the market in the past. So a few years ago, FARO announced what's called a flash for our FARO premium scanner. This is the ability to take a PanoCam, a 360 camera, and be able to quickly enhance the scan. So you're talking about what used to be a 2.5 minute scan down to 28 seconds. So I'll go into that in a little bit more detail. But you're getting more scan time, more scan data in less time, complete scan workflows on one device, reduces your labor costs, reduces your risks, right? The less time you're on a site, the less risk of any issues. And then cloud collaboration, as we talked about in my first slide, being able to bring that data into a cloud solution so that your users can use both your premium data that was captured in one area, as well as that flash data. And then the same goes with our Orbis scanner, right? So both of these hybrid scanning technologies are available on both scanners. We just covered this kind of on another slide, but I just want to kind of highlight this again because I'm a visual person. So when we talk about the Focus Premium, we talk about them in stations, or we talk about them as setups, right? You're going around a room of this size or a building of this size, and we need to capture this in high accuracy with color in HDR. A site like this, I think we mapped it out to be about 21 stations, would take about 1 hour at the highest resolution. So each of those scans would have the highest amount of detail and precision with color images, generally around 3 minutes per scan. Some of the users on this call are definitely used to this. I think 27% of you, or I think it was around that, are used to this setup. When we talk about flash, we talk about within that same scan, whether this example here is showing all of flash, but just think of the areas that you might just use flash within the same project. In this particular case, we did 21 stations, 21 setups, and we captured the entire scan in 25 minutes. So a much increased, 4 times faster data collection with very little trade-off between the two types of scans. This again reduces drastically the amount of time a customer's on site and very little trade-off on the detail. When we talk about SLAM, again, we're not talking about the same accuracy levels, but we're talking about a much quicker scan. So 2.5 minutes, this is very typical. When I go on a customer site, it's generally less than 5 minutes. We can capture their entire office building. And you start and stop in the same location. You're walking around, this line here is your trajectory, your line of path, and allows you to walk through that space in a brisk pace. You may give up some accuracy, of course, compared to that premium, but you can get a lot more data in a shorter period of time. So again, less than 3 minutes to capture this entire environment. When we include flash on the scanner, which I'll go over how that works, again, we are increasing the time. So we're doing the opposite that we did with the premium, but we're getting more precision data. So throughout that scan, I can decide whether to use flash for the entirety of that scan or use it in collaboration with my regular mobile SLAM data. So when I come up to an electrical panel, an overhead piping, conduit, mechanical rooms, things where there, it's very small detail, a mobile scanner generally has trouble with those areas. We have now introduced the ability to capture that with the same scanner. Again, we're still under 6 minutes on the overall scan time. Looking at time, so 12:46. So I just want to make sure we get through everything. So I'll fly through some of these, Chris, and I'll throw it over to you. But for the Focus Premium Flash, right? So we are adding a camera essentially on top of our scanner. There's also a built-in camera inside of the scanner. But for this case, we're able to use that PanoCam to essentially help assist the laser data, allowing the user to only do 28-second scans. So what normally would take, 1 minute up for a black and white scan, up to 2.5 minutes when you're doing color. Fantastic accuracy, as I mentioned, 1 to 2 mils on that. Up to 2 million points per second with a standard capture. On a flash data set, we're talking 28-second scans. We are doing some upscaling. It is a color-only scan. The accuracy is fantastic, and your points are similar in the 20 million point range at that similar area. So we are doing quite a bit of magic in the background to get to that level. This is a wordy slide. I'll throw this up here and talk through a couple of them. But more importantly, this is just for you guys to read through. when we describe this to the market, we get a lot of customers that say, are we manufacturing data? This is an upscaling, of course. When you use hybrid, we are including that camera in our processing. But when you look at the trade-off between the data points, there really isn't a lot to talk about. When you talk about flash scans, we are talking about the same accuracy data that we're getting with our premium scanner in traditional mode. So it does give us quite a bit of flexibility when we're on site, whether or not we can capture certain environments using flash or standard. So again, just to remind you, like the hybrid reality capture with the flash technology is on our premium scanner only. It does not backdate to some of our previous scans. We control the flash with what we call a stream app, which is just a mobile app, and we tell the scanner when we want to use flash or when we don't. Auto processing. So again, when we go into our software, this is where the software itself will take that data and interpret it. When we talk about flash, again, what is it good for? When would I use flash over a standard data capture? So on a large project, Kelly covered some of this before, on a large project with lower level of detail. Why? Because sometimes there's occlusions in that camera data that might not show up in a lower level scan, right? So you would want to, this great image down here, this mechanical room with all this piping and things like that, you still want to capture this in high detail. But in the scan to BIM world, you're doing construction progress, you want to get in and out of a site in quick time. This is a perfect solution for that area. This is just a quick example of what this scan looks like. So let me start that over here. On the left is just our standard data capture with a focus. And then on the right is our flash. So you'll see quickly that scanner is rotating 360. And as it's capturing, it is not capturing the full environment in high definition, right? We are then taking a quick snapshot right at the end and using those two data points in combination to get a 50% quicker scan. And again, Chris, I'm looking at time, so I'm trying to breeze through these. But essentially, the FARO Orbis, again, introduces the same kind of idea, right? Flash technology, but going in the other direction. Mobile scanning has historically been a less accurate scanner than a terrestrial scanner. Flash technology is now getting the mobile data into the same realm or similar realm of a terrestrial laser scanner. So in the scanner, I think, Kelly, you showed it as the mobile scanner Orbis was a handheld scanner. We now introduced a monopod. We do this so that we can then capture these flash scans with great detail. So when we think about SLAM, we think of fast capture, color, great accuracy, 120-meter range with the Orbis scanner, 600,000 points per second. When we stop and do a 15-second flash scan, we get better color, we get better accuracy, we get 80 meters of range and 20 million points. So you can see on the screen here, the left and right shows you examples if I had just walked by that scan or that area with that scanner, or if I stopped and did a 15-second scan. The data is quite remarkable. So again, just kind of how that works, right? So when we compare this to terrestrial data, I tell customers it's a terrestrial scan, because the output is actually a structured E57 versus SLAM data, which is an unstructured data set, because as you walk through the scene, as opposed to a terrestrial scan that's at a given location, you're moving through the scene. So any point on the wall could have been captured from any degree. When you capture in a flash scan, we are essentially capturing it as a terrestrial scanner, right? So you are getting a structured data set. Oops, there's more there. So talk about precision. Again, Kelly was talking about accuracy of 5 to 10 mils. That is still the case with mobile data sets. When we're doing a flash scan, we can expect the the precision between about 2 and 5 millimeters, which is exceptional for mobile data. We're still doing excellent scan times, right? So in that example, I showed 2.5 minutes to 6 minutes. So we're still in that realm of great scan times. I'm gonna fly through this video, Chris, just because I see that we're running, don't want to run out too much time here. But essentially, this is how the Orbis scanner is operational, right? So we have what's called a stream app. You can also use the physical buttons, but essentially you start and stop the location, or you start to stop the scanner at the same location. So my colleague Rob here is starting the scanner, and then the scanner itself will tell you, go ahead, you can start. He's gonna then walk through the environment and start capturing. So as I talked about before, as opposed to a terrestrial scanner, you're not limited to a single location. You are physically walking through that space. Again, just because we're running out of time, I want to get through some of this here. but I'll kind of fast forward to where he takes a terrestrial scan. So even though he's not using the monopod, he stops and he takes a 15-second scan. So super easy to do. It's getting a lot more information and a lot higher precision data. Once the 15 seconds is complete, then in this case, Rob would continue walking through the environment. What's most important about the terrestrial scan taken from the Orbis scanner is the fact that registration is automatic. It automatically gets registered via SLAM algorithm. So that data is registered to our SLAM data automatically. I'm going to fast forward kind of to the end of the scan. Rob passes through here, and he comes back to his stop location, and we'll end that scan. So super, super easy to use. I can train a customer in a couple of hours. What is the result, right? Orbis SLAM data is this, right? You're able to capture a massive, massive environment this was probably done in less than 10 minutes, right? With flash data incorporated. So I'm going to fly through a couple just screenshots to give you an idea of what that looks like. So again, with a mobile scanner, something like this would be very difficult to pick up, right? All these fine conduit lines, these small rebar, this would be difficult on a mobile scanner. Flash is now enabling that to be possible. So again, looking at the pipe fittings and screws and things like that, that is something that, again, historically has not been possible. But where this comes into, the fact that we're able to use a single tool to do a single environment, right? So this is not replacing a terrestrial scanner by any means. But if you look at a site like this that could take a week to capture, this is where Orbis SLAM data with Flash is a possible solution that could capture in a very short period of time. So again, just bridging the gap, just to kind of close out my remarks, and then I'll pass it over, between terrestrial scanners and SLAM scanners, right, is something we're calling Flash, hybrid reality capture, and the ability to get in and out of a site very quickly. So Focus Premium, Flash is used by using this third-party camera. We capture a 28-second scan. It includes HDR imagery, very, very high accuracy, 20 million points. So when we talk about Orbis, we're also talking about Flash, but it's in the opposite direction, maybe a little bit slower in the scan time, 15 seconds per scan, but we're getting a lot more accuracy and precision over a mobile scanner. So at this time, we'll take our third poll question, and then I will pass it over. If that pops up, great. What can FARO do for you next? Schedule a FARO Orbis demo, provide FARO Orbis quote, request more info on FARO Orbis, or nothing at this time. So we'll go ahead and let you guys answer that. I'll let Chris jump into this, and then we'll jump into the Q&A section after this. Chris is going to cover Orbis and the Focus Premium in the real world. Chris?
Thanks, David. So we're going to go here and show some data, some actual live data. So our test case is we went out and visited a refined products facility. We wanted to capture our normal process is TLS scanning with a FARO 350. Our average, we want to collect color, HDR. So our example in this case was about 15,000 square feet of space. It covered about 24 scans, about 6 minutes of scan time with color HDR photos. It takes about with targeted registration, so it's about 8 minutes per scan, about a little over 3 hours to collect this amount of data. And what we're showing now is FARO Scene. This is the registration software we use for TLS scanning. There's an overview map showing all the locations of the scans. We'll get into the actual point cloud. Here's the data. This is a manifold area. We'll dig in, actually look at some of the data. So this is, as a TLS scan, as Kelly mentioned before, there's always a little bit of a circle underneath the scanner that you can't see. There's the scanner head. You can see there was some blank data. The targeted spheres, as you see, these need to be moved through every scan. I mentioned 24 scans, 3.5 hours. This is great data, but it takes 3.5 hours. With the camera, this is a camera view of that scan that we just noticed. Great imagery, great data, but again, 6 to 8 minutes per scan. Takes a long time. Safety, especially if the operation is running, it's a big concern of ours. We love this data. We consume it all the time. We looked at trying to find a way to capture the data faster, just as safely, but have the rich data and the color. Very important for our engineers that don't visit the site to be able to use this application to visit virtually a site without having to step foot on site. There are hazards that we run into when we come to these sites, so safety is a big concern for us. The amount of time we spend on site is a big concern. We're looking for alternatives. With those alternatives, as they mentioned, the flash data with the Orbis, we have an application we use to consume that. It's called Connect. So as we're showing here, this is the same area, about 15,000 square feet of the same manifold in a refined products facility that we scanned using the Orbis. The Orbis was this same amount of data. You can see the red path. I walked it at normal pace and included 32 flash scans. And this whole facility, in this case, took less than 25 minutes to capture. And we'll zoom into some of the data here because this is what's important. So what I'm showing in this case is the full mobile data without color applied. We can't apply color. This is just the raw data in its native state. If I turn that off and go to a colorized, you can see we lose a little bit of range, but we do apply color from the pictures. The Orbis does take a picture front and back about every few feet. And I'll show that. The problem is you have to make sure you get your head out of the way. But as we see now, we have thousands of pictures of the site without having to take a camera with us. This is very rich data, and we can apply color. We can apply the color of the imagery to the scans, or we can look at it just as the photo. This images we're seeing right here has the camera view from the Orbis, and it had the point cloud in the background. We can turn those off, so we're just looking at the photo. Again, a very safe way to visit a site without actually having boots on the ground. This is great data, and as you can see, every few feet, depends on how fast you walk, there is a photo that you can measure distances and see what you need to see. We can go back to the point data. This is great. Let's go back to the point data. Let's look at some of the flash scans. We'll exit the panel. Let's look at the flash data. These are 15-second flash scans. As you can see, the data is even much better. We get into an environment here where we can see. And let's turn the photos off. As you can see, that's pretty good data. That's a 15-second scan. We like to incorporate that with the mobile. As we turn that on, you can see we are very rich data. Not quite the level of the terrestrial scanner, but we spent a fraction of the time on site collecting the same data, fraction of the time. We have found that this is a very good workflow for us to limit the number of people on site, limit the amount of time on site, and improve our safety factor by 5 with collecting the same amount of data. As most surveyors will recognize, we don't need 1 to 2 millimeter accuracy on every piece of pipe, every flange in these scenarios. We only needed it at targeted locations. We were able to capture the data much faster with the Orbis than we could with the terrestrial scan. I'll go back to show the difference. You can actually see the difference in the scan. Let me shut off the mobile. There's the colorized scan. Really good data, really good data. We were able to model from this pipe, the pumps, the foundations, the sidewalk. We were able to model this in CAD. I'll toggle back to FARO scene to see the difference. This again is our terrestrial scan data. Very good, but again, took 3.5 hours to capture the same area, 24 scans. The Orbis data, here again, Orbis data, less than 25 minutes to capture that whole thing. We have found that this is not in our opinion, it's not a replacement to our TLS scanner, but it is a tool that supplements our TLS scanning. We can spend a lot less time. We would have 5 terrestrial scans in this location if we incorporate the Orbis data as well. So we're still less than an hour, less than 45 minutes on site to capture all of the data we needed for this project.
Chris, thanks for going through that. Again, great data on both scanners. I think you were able to capture quite a bit of data in quite a short period of time. So that's fantastic. And thanks for working with us on that, of course. So at this time, we're going to jump more into just a panel discussion. So we'll go into kind of just some back and forth and maybe discuss kind of how that project worked for you. Then we'll jump into more Q&A. So it looks like we have about 16 questions. So great. Thank you for that. We'll go through that here in a moment. And then we'll leave you guys with the rest of your day. So I guess I'll oops, I'm kind of sliding through here. I'll kind of kick that off, Chris, and ask you kind of more, you talk about safety, right? So bringing this type of equipment into an environment like that, there's tripping hazards, there's things that could get in the way. And I'm assuming there's teams on site that are watching you. When you think of a terrestrial scanner, your focus, and then you talk about your mobile scanner, right? What are some of the trade-offs there on the safety of using both of those pieces of equipment?
So the safety aspect is all about time. They're both not intrinsically safe devices. So like in our case, in midstream oil and gas, we have to get a hot work permit to operate in those areas because there are combustible materials. We want to spend the least amount of time on site as possible, simply because there are hazards. We have found terrestrial scanning is great for data, but it takes time. We are currently set up with a Focus 350, which takes us about 6 to 8 minutes per scan location, because we want to collect color in HDR. It's a little older scanner, but the data is still great. What we're finding in this case with the Orbis, we spent a fraction of the time on site to capture the same amount of data. The less time on site, of course, is much safer. The trips, hazards. With the terrestrial scanner, you have to do a lot more walking because you have to move, as you saw in the terrestrial scans. We have to move targets. We do targeted registration because most of our stuff is outside. So we need globes. We need 6 per scene at a minimum. So we have to transfer those. We have to have 6 in each scan so that we can target. That takes a lot of time. It takes 6 minutes to scan, but it takes a couple minutes to move the targets. You're walking back and forth over all these hazards, spending a lot more time there when the mobile is so much faster. No targets required. It will register automatically with the SLAM technology.
Chris, can you let us know what quality and resolution settings you're using off the top of your head for the 8-minute scan?
Yeah, so the Focus 350 right now on this project, we used we're running I think a 3x, about 43 million points per scan, and then we're running 2 times HDR. So it runs us about 6 minutes, I think, in scan, and then we figure about 2 minutes to move the spheres to the new location.
Wonderful, thank you. And with Chris is using our version 8 of the scanner. With our version 9, we've about cut times in half as well for the scan data. So you can still expect 2 minutes for the HD scan, but we've bypassed that by using the 360 camera. So for average scan times using the Focus Premium with the panel cam, you're looking around 2 minutes average a scan using the internal HD camera with the scan time. So between 127 with the panel cam, between 127 and 248 in our quality and resolution. And then with that premium HD image, we're looking at 3 to 4 minutes a scan. So just thinking about the difference between the version 8 and version 9, still great data, but we have exponentially increased the scanning speed. Thanks.
Yes. Yep. Ours is, as I mentioned, is a little older.
Yep.
Yep.
Still a great scanner, but just wanted to
Oh, yeah.
note that with the new series, we've also increased the scanning speed
Yep.
as well. So, and thank you so much, Chris. I really for the comparison between the two. It's great to see it live.
I have one more question, if you don't mind. So, Chris, one thing that comes up quite a bit when we demonstrate this customer, especially the oil and gas, the fact that you can't get a terrestrial scanner very easily underneath large equipment, right? So,
Yep.
getting the bottom of that equipment maybe is close to the ground. Were you able to use the Orbis scanner in a way that you're able to kind of get in and out of environments at all that maybe weren't even possible before?
Yes. So access is a big thing as well. So with the terrestrial scanner, it's hard to get up on tanks, for example, or high platforms, ladders, safety cages. You can't really bring the terrestrial scanner up there. What we're able to do with the Orbis is you're just going to walk. If you can walk it, if you can climb a ladder, you can take the Orbis with you. I was able to walk up on top of the tank while scanning and capture all the data that normally we wouldn't go up there. We were able to climb up on platforms, get underneath vessels that a terrestrial scanner, we wouldn't be able to do that. So we're not just scanning the same amount of data, we're getting actually more data because we can get in those tight spaces that we couldn't get into before.
And I guess on the data side of things, and maybe you haven't gotten to that stage because you just scanned this project. If you were going to do the registration between the two scanners, have you had a chance to do that? And if so, would you kind of walk us through a little bit of that process?
So I didn't register because this was our test pilot project for the Orbis. I had Kelly do the registration for the Orbis. But for us, we figure 1-to-1. So if it takes 4 hours in the field to capture the data, we account about 4 hours to register the scans and georeference and export. We export out to recap for consuming in our CAD products. So we figure about a 1-to-1. So if it's 4 hours to scan, it's 4 hours to post-process, clean the data, georeference it, and get it into our CAD platforms.
Great. Did we want to jump into the Q&A, Kelly, or do you have any other questions there?
I think that's great. Yeah, and as far as processing time, the time took a little bit longer to process because my C drive was mostly full. So again, all of those things come into play when you're working on data. Is how much space do you have available? How much RAM do you have? How many cores do you have? And we can follow up with specific specs that you'll want to use with any sort of laser scan data. We want to have a higher quality computer. But yeah, let's go ahead and jump to the Q&A. I figure we can just start at the top. I see, what is the final submission and where and soft we need to finalize the job. So how do we get the software into Revit or BIM? So from our finalized point cloud, we have an E57 file, or Scene's native file is a FLS file. We can bring the connect data into Scene and export out a recap file directly from Scene, which is our registration software. And then using our software called As-Built. As-Built is a plugin for Revit, for AutoCAD, and a standalone function called As-Built Modeler. That allows us to put the recap file or the RCS file, so a portion of it, or the entire product into recap into Revit or As-Built. So within Scene or Connect, we have many different types of point cloud files that it can generate. So we have E57s. There's probably 20 different ways we can export it out. But in order to get into the BIM process, we want to create that recap file using the export, or you can bring it into recap. And usually if you have an Autodesk program, recap is free to do the conversion to bring that in to work with the modeling software.
Yep. In our case, that's our workflow. Is we go from FARO Scene, we clean everything, we process, then we export to recap, and then recap is our consumable product that we use to get into AutoCAD, Civil 3D, Revit, Navisworks, all of the Autodesk products, Plant 3D.
Great. Second question, how much light is needed for the scanner to return high quality scans? So great question, Amelia. Laser scanners are their own light source. So if you need a black and white scan, there is no restriction on the number or the amount of light that you need in a room to get a good scan, right? So you could take an Orbis or premium scan in a pitch dark scan or pitch dark room. Where you need light is if you need RGB values. If you need that camera to capture information and then colorize the scan, we do need adequate light for that. Whether you're introducing the light yourself with a mining helmet or overhead lighting, you would need that for RGB information.
To add to that as well, the premium has different settings where you can say that the light is coming in from the top or the bottom, and it will then filter out that light to give you a better RGB value. So in the static scanner, we have different settings to account for that. With the Orbis scanner, like Dave said, you'd probably introduce your own lighting. All right, next question. I see more of a comment. I use LiDAR for the film industry and TV. I actually did a training for a company that does their setups for Louis Vuitton. So they go in there, they pre-scan all of the area that they want to do their setups and put all their bags. And they actually did a really cool 3D model of, it's kind of a gentleman in a top hat. So all sorts of things we can scan. So not the first, but what a cool application.
And just to comment on that, mobile LiDAR is perfectly fine for something like that, right? If you need even in a foot of accuracy, you could probably use a camera there. But I think, yeah, mobile scanning is perfectly fine for something like that.
Okay.
The next question, with an external data logger, can that be used simultaneous with the cloud upload? I think you're referring to, so both of our scanners, they capture data onto a device, right? Premium could be onto an SD card or whatever it may be. And I think you're referring to the external data logger on the scanner, the Orbis scanner. So the way that Orbis works, we are capturing information and you have a screen, you can follow that in real time. We'll read out the cloud itself, but that does need to be processed on either on site or in the cloud. So we do have to have that processed after the fact. So if you're doing cloud, the way you do that, and it was in that video, but I kind of flew through it. Essentially, you download the data to your device, that's your phone or your computer, and then you push it to the cloud for processing. So we can process SLAM on our Sphere XG platform. Alternatively, we also have a local process. So you can do it right on your computer on site or in the office. I think that answered the question.
Yeah.
You want that one, Kelly?
Orbis. Let's read through. Absolute accuracy between points on one side of the building and points on the other side. Is this relative accuracy or within a localized area? Is this survey control? How much?
I think you're referring to that to the building slide where I showed accuracy, right? So keep in mind when we talk about accuracy, we're always talking about the distance from that scanner to an object. So that doesn't matter what type of scanner it is. Every scanner has an accuracy setting based on how far that light has to travel to hit something. And every laser scanner on the market has kind of an accuracy spec for that. So keep in mind when we talk about mobile data, we have to tell customers that you are that distance, right? Whether you get up to an object or not is depending on how close you can get to the object. So when we talk about accuracy, it really is dependent on the user in that case. And because you're talking about centimeters, I assume you're asking, oh, sorry, you did talk about Orbis. So if you want a more accurate scan, there's two ways of doing that. You're gonna get closer to an object. So get closer to that wall, that object. And we're talking closer, we're talking about 10 feet or so, right? Or you're gonna be using control. As you mentioned, spheres, checkerboard targets, we can bring all that into the scan. Or you can bring in terrestrial scan and use cloud-to-cloud registration to even fine tune that data as well. So when we talk about accuracy, we're talking about the specs of that scanner out of the box. But to your point, yes, we can get very, very high accurate information, 5 mils, or lower using targets.
I see Richard also has a question a little bit further diving into survey control and is requesting a video geared towards surveyors. With our new interactive registration, we also have more control over each connection between the scans. So we can actually kind of bypass that cloud to cloud and go in and do an interactive registration where we define which scans are connected to one another. And that's going to give us a much tighter registration. And then there's also a new way to apply survey control. So I will take your information and follow up. Our colleague Brandon has a really great video. Actually, he's been working with clients for this exact question. So I will follow up with that information for you, Richard. All right. The next question, you mentioned SLAM could have a top-down view. What is the height of the range of the trees? When we're talking about that top-down view, in the live scan, we have the app that you can visually see it come in a top-down view. So, you know, as long as you're within the range of the scanner and there's nothing blocking the line of sight, the Orbis should be able to hit the top of those trees. Right, Dave?
Yeah, so the range of the scanner is 120 meters, so that's 300 plus feet for us US folks, but essentially keep in mind that that is line of sight from the scanner. You know, if you're shooting a tree, an example, you're shooting it from the ground, so that would be from that ground location. The Orbis scanner, the Orbis scanner is not positioned to fly. FARO does offer a couple other GeoSLAM scanners that can be placed on a UAV. So you could capture the canopy of the trees with that type of scanner. But 300, 330 feet, something like that is what the Orbis can capture. The next question, Mario, how can you extract the information to make kind of inventory of objects? For example, counting light poles or trees and traffic lights, any other objects in 3D space. Chris, did you want to take that one?
So I guess it depends on what you're asking for extract. What we do is we bring it into recap, as I said, and we model and we use, as Kelly mentioned, we do use as-built to help us in our modeling. It's a great tool to speed our modeling up. We are not yet with the ability to count the light poles and the trees in the software currently with the FARO software, but we use it. We just consume the point cloud and model those things in 3D.
We do have within the as-built plugin inside of AutoCAD, we have a way to find all of the cylinders available. So you would do a clipping, only kind of focus in on the area that you want because it will find the cylinders everywhere in the point cloud. So if you have a really large point cloud, that's not going to find it. But right now, really what people are extracting are different types of geometries. It's regions, planes, cylinders. There's not, I know Recap is moving forward on being able to extract these types of things, you know, in space and time. But right now, like Chris said, we're just limited to certain geometric shapes. If you know of a software that can extract a tree and know it's a tree, that would be amazing.
It's coming. It's coming with AI. I've seen some beta things that they're running an AI algorithm on the cloud and being able to find like items like fire hydrants and power poles and things like that. So it's coming. It's just not currently in anyone's software that I'm aware of.
It does exist in software today. Like to your point, Chris, it's getting better, and it's kind of scary how good it's getting. I hate to say it, but there's some users out there that won't have, you know. Anyways, the next question: how does Orbis Hybrid SLAM flash speed and quality compare to, say, an older scanner like the M70? You want to take that one, Kelly?
Well, I don't have the spec sheet for the M70, but I do have the S series scanner. Like I said before, we're 40% faster in the premium than the S series. So the M came a little bit before the S. So it's significantly faster, 40%. Also making sure you upgrade to the newest version of Scene. We have newer algorithms in there that help process faster. So usually if you're using an older version of the hardware, you might be using an older version of the software as well. So I'd say roughly 40% faster than the M70. And then like you said, that's just for the Flash Premium alone. Orbis, you can see we captured an area in 20 minutes versus 3 hours. So we'd be happy to hey Pete, I think is that Kenosha? Sorry, I just saw the name. Like, we're gonna come do a demo for you. Much faster.
Much faster for the M70, and the range is quite a bit better too. The Orbis range is 120 meters. And if you're doing flash, it's even 80 meters. So you're getting better range and much faster speed.
So we have 7 minutes left. So I want to try to get through some of these questions. And if we don't get through all of them, we will contact you after the call and be happy to answer that. Xingxi said, for an international project funded by the UKRI, who or which department is the right person or place to know the solutions to get the proper instrument for each study site? So I think you're asking like inside of the project itself, who is the right person or people or departments that I guess it's going to depend on that actual project. Generally, when we talk to customers, we try to talk to the owners, the project managers, the people that are using the scanners. We try to touch every single member that might actually be part of that purchase process. I think that's part of the question. If you're asking the other way, who at FARO to contact, we can send you some information on that after the call. Wade Williams, is that Wade Williams of FARO? Will you explain global accuracy versus local accuracy and the factors that affect them? So I can talk about it in SLAM. So the way that SLAM works is we have a global and a local SLAM. What does that mean, right? So every 1 second, SLAM is trying to figure out a bunch of math to put a bunch of vector information together, right? Where are all these points in a physical space? That is local accuracy. When we talk about local accuracy, it's right in that 1 second of given space. We call it a voxel. When we do a global transformation, that's taking all these different voxels that we captured along the way. So in Chris's way, 20 minutes around that entire oil and gas, it's doing a overall adjustment of that point cloud to then put those pieces all together. Where was I 1 second ago, 30 seconds ago, 45 seconds ago? So when we talk about accuracy, we definitely talk about it local and global. So in that 1 second of information, what is my local accuracy versus here to the other side of that site? In my eyes, that's how I define those two accuracies.
Yeah, that's a good way. I can say for static scanning, we can talk about if you have a really large project, usually we break them into clusters, right? So if we have 4 different levels, each level would have a cluster. So each cluster has a local accuracy, and then we want to combine those 4 clusters into one large project, and then we have a global accuracy. So like Dave said, we can break it down into smaller areas versus the larger project. And then, bringing in survey and control that also can affect your global accuracy and how you want to tie that in. So,
yeah, and just because we have 67% of people who have never touched a laser scanner, the way that light works, right, and every scanner is the same, that light exits the machine, and the farther it gets away, the less accurate that return is going to be. And that could be for atmospheric purposes. It could be something totally different, lighting conditions in the room, maybe, or the sunlight. It could be fog, it could be rain, whatever the environment is, that light's never going to come back at the same rate the farther it gets away.
And for outdoor scanning, be sure we mention that you can't scan water, you can't scan in the rain. Very shiny objects, stainless steel. We sometimes have issues with stainless steel. If there's water, if it just rains and there's water on the road, there's ponding, it won't scan, it just disappears. So for people that are new, things that are wet, we can't scan.
Reflections can be a
4 more minutes, Kelly. Let's knock some of these out.
Right.
Ready for some Q&A.
Okay. How much does the mobile, excuse me, don't want to skip one. We talked about lighting already for the room, taking measurements in Sphere XG. Data is collected by multiple devices. How does the user confirm which data set is being used? The accuracy of the measurement. So inside of Scene, we have a registration report that we can bring all of our TLS scans together and see what the accuracy is. Within GeoSLAM, the Orbis scanner, Dave, I'll let you talk about the accuracy of that, because it doesn't actually produce a report, but you could take like a known measurement of an object and confirm a door width is 3 feet. So if you do a measurement and it's not 3 feet, then maybe we need to go back and do some scanning.
every scanner that we talked about has a measurement spec. And is your scan going to be that measurement or that spec every single time? No, it depends on how you use the equipment. I think your question, Wade, was more about in Sphere XG, how do I know which point cloud am I using so that I know the accuracy threshold. And that's just a toggle on and off. Unless you're merging all your terrestrial data and all your SLAM data together, which most users won't do, what they'll do is they'll use them to register each, but then there's separate point clouds. And inside of Sphere XG, you'll just highlight which cloud that you actually want to take a measurement from.
Yep, because it could be from different users. Different users may need different technology. We like on the civil end where I reside, we like the mobile data because it's not as heavy and I can collect a lot more data. I can collect a lot more topo with the Orbis that is much harder to collect with the terrestrial scanner, where our piping and our survey structural guys want more of the flash scans because it's much more accurate and much more dense in those spaces for 3D modeling.
We're going to fly through the last question. We got 1 minute here. So how much does the mobile scanner weigh? So we'll send the exact specs over. I think it's around 2 or 3 pounds. What is the best solution for volume modeling and computation? Again, it's going to depend on the error that you want to consider. So, you know, within a threshold of each scanner has their accuracy thresholds, but both are point cloud softwares. Both are outputting point clouds. So volumetrics is perfectly fine with either. Can the FARO system of data capture technology work in sync with other solutions, especially when it comes to aerial data capture? Great question. Absolutely.
Yes.
Photogrammetry and LiDAR data play very nicely together. The outputs, you can actually output them very similarly to the same platforms. So they play nicely together. And as I mentioned in a previous discussion, the Horizon, which is another FARO equipment, can be flown on a UAV. So you can capture that also from the sky with photogrammetry. I see you're using a Theta 360 camera for photos. I don't like the model due to the lack of removable SD cards. Is it possible to use another 360 camera with that media? I believe with the premium, we are only using the Theta. If you're using photogrammetry in any other capacity, Chris will tell you on site, what's most important is they need to get site progress or whatever it may be. You can use any camera you want and bring that into any point cloud software, whether it's Scene or another one out there. So for Flash, I believe it's only the Theta 360 that we've programmed our system for. Can any of these products be used on a vessel for surface positioning? I don't know I know that question, Kelly. Does that make sense to you?
I was going through and answering some questions via typing, just to make sure we got it. Sorry. You said which one?
Sorry. Can any of these products be used on a vessel for surface positioning? So I think he's talking about boat positioning, maybe. I assume that's what the vessel he's talking about there. Again, there's no GPS on either of these pieces of equipment, right? So you would need to introduce that if you're looking to have a position of real world information, right? You have to have some additional GNSS receiver in order to incorporate that. But we can absolutely include that in our products. Is there education? Oops, go ahead.
I was going to say I answered via type. A lot of our modeling or our software is on knowledge base, knowledge.faro.com. We can do volumetric calculations within Build It as well as in As Built. So check out knowledge.faro.com for the other applications for the volumes. Those are the questions I was answering. And then we can dive deeper into your vessel for surface positioning. And then education discount. I believe we work with different educators kind of on there's not a plan per se, but we just work with you directly. We can provide trials. We can give 30-day trials for any of the softwares that we've been discussing here today. So you can try them out fully.
Absolutely, on both hardware and software. Yep. We're over time, so I think we'll stop there unless anyone else on the panel has anything else to add. Great, we did it. We got through it. We really appreciate, again, XYHT and everyone putting on the panel today. I thank you, Kelly and Chris, for joining today, of course. I think this went really well. We will absolutely, if you have any additional questions, please send those to us. We'll be happy to answer those. And yeah, enjoy the rest of your day. We really appreciate your time today.
Thank you,
Thanks,
Dave.
everyone.
Thanks,
Thank
everyone.
you, Chris. And thanks, XYHT Magazine, for having us. And thanks to our participants.